Okay, we're going to skip problem number 8 because we didn't do the story problems for that section, so that's not going to be on the final exam. So let's look at problem number 10. Problem number 10 says you solve by using the quadratic formula. So we have x squared plus 5x equals 7. Now, before you use the quadratic formula, you need to put the quadratic equation into standard form. And standard form has it set equal to 0. So that's x squared plus 5x minus 7 equals 0. The quadratic formula is they completed the square and figured out what every x is. When it's in this form, then we can use this right here. This coefficient in the front is a. So a equals 1, and whatever coefficient, once it's in standard form, that's right here is going to be my b. So b is 5, and right here at the back is my c. So c equals negative 7. So standard form looks like this: ax squared plus bx plus c equals 0. So whatever numbers fall into those spots when we have something in this form are my a, b, and c. And we're just going to put them into the quadratic formula. And the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So we just plug in a, b, and c into that formula, and we get our solutions for x. So x equals negative 5, b just pops right into that spot, plus or minus b squared minus 4 times a times c all over 2 times a. Okay, now from this point, the hardest part, I think, is order of operations. Don't forget that your order of operations says I've got to do this exponent business first, then the multiplication. Don't do that subtraction until the very, very end inside of this. Now, a square root is kind of like an implied parenthesis, so we've got to do what's inside of here first. So let's do that. X equals negative 5 plus or minus square root 25. Multiply all these things together and you get plus 28 all over 2. All right, now I can add those two things together and I get 53. 5 plus or minus radical 53 over 2. And that actually, I think, is my answer. I don't think that 53 simplifies. Oops, I left off that. This is two answers. So you could see the answer given like this, consolidated into one, but this is in fact two things. This is negative 5 minus radical 53 over 2, and negative 5 plus radical 53 over 2. Those are my two solutions for this problem. So that's problem number 10. Let's look at problem number 11. See, now problem number 12 uses imaginary numbers, so you're going to want to skip that one. And problem number 13 does as well, so you're going to want to skip number 13 also. So let's just look at problem number 11. Let's do 11 together. We have t plus 3, t minus 4 equals negative 2. All right, so this is all nicely factored. Okay, but what it's not is solvable like this. Factored and set equal to 0 is something. If this was set equal to 0 instead of this negative 2, we'd be in great shape. We could set each of these pieces equal to 0. That's the 0 factor property. Things that are multiplied together equaling 0, one of those things equals 0. Either one of them being equal to 0 would make it true. So since this is not equal to 0, we've got to get it equal to 0. So I could add over there. And how does that look? It's just going to like tack onto the end. Also not helpful. So yes, we have to multiply the whole thing out, FOIL this out. This is going to be t squared minus 4t plus 3t minus 12 equals negative 2. Add 2 to both sides of the equation. You get t squared minus 4t, no, let's simplify that, minus t minus 10 equals 0. Now, does that factors of 10 that are going to give me a difference of 1? No, 5 and 2 give you, 5 and 2 give you a 3. All right, so let's use the quadratic formula. T, here, this is in this form right here, but instead of x's, we have t. So t equals negative b. Okay, b right here is negative 1. A equals 1. C here equals negative 10. X equals negative b. Negative negative 1 is a positive 1. Plus or minus square root b squared, put that in parentheses, minus 4ac all over 2a times 1. All right, so order of operations, 1 plus 40 plus or minus, and that's a 1 over there and 2. All right, t equals this. All right, so this is the square root of 41, which is nothing. There's no simplifying it. So we have 1 plus or minus radical 41 over 2. Now you could write it out separately, so you had 1 minus radical 41 over 2, and also 1 plus radical 41 over 2. It's often seen this way though. Please know that it's 2 answers because of the plus and the minus, but it's often written all consolidated like that. All right, that's number 11. Let's skip now to number 14. 12 and 13 have imaginary numbers in them, which, as I said before, we're not doing. So let's look at what 14 looks like. 14 says x, 2x minus 7 equals 3x squared plus 3. Okay, so this is useless again, the way that it's written. So we need to multiply everything out and set it equal to 0. Whether we're solving by the quadratic formula or with factoring, in either case, we set it equal to 0. So let's multiply through here. We have 2x squared minus 7x equals 3x squared plus 3. Okay, let's subtract 2x squared and add 7x. And that gives us 0 equals x squared plus 7x plus 3. Okay, so this is going to require the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so we have 49 minus 12. What is that, 37? So we have negative 7 plus or minus radical 37 over 2. And then if this radical 37 could simplify, if what's inside of here could simplify, you need to do that. But it doesn't. So that's it for problem number 14. Let's look at problem number 16 and 18. Problem number 16 and 18 talk about the discriminant. Now the discriminant is this little part right here of the quadratic formula. It's this part right here that's underneath the square root. Now on this one, remember we got radical 37. What that means, and because it didn't simplify, and we had a radical in our answer, it means that I have irrational answers. We had plus or minus radical 37. That meant I have 2 irrational answers. Irrational, it has that square root in it. Now, if it had gobbled up the whole entire square root, like if we had a 25, square root of 25, I could make that into a 5. Then it wouldn't be irrational because I didn't have that square root left in my answer. Those would be rational answers. So that's what is being asked of us in problem number 16 and 18. So let's look at number 16. It says 4t squared minus 3 minus 4t. And what they're asking is, what kinds of solutions are we going to have and how many? So we need to put it still into the right form so that we know what our A, B, and C are. And we're going to put them right here into this right here. So I have b squared minus 4ac. So I have 16 plus, what's 16 times 3? 48? 16 times 3 is 48, and 48 plus 16 is 64. Okay, so if we can imagine this b squared minus 4ac being 64. Imagine if you had stuff in here, those numbers had gone into that spot, and I had plus or minus the square root of 64. Can I take the square root of 64 and have no radical left behind? Yes. What's the square root of 64? 8. So because of that, then I'm going to have a number plus 8 divided by something, and a number minus 8 divided by something. So those are rational. Rational numbers are numbers that you can write as a fraction, or whole numbers, or integers. They can have pluses and negatives. They can be positive or negative, and they can be written as a fraction, but no square roots in them. So what we're going to have is a plus or minus radical 64. It's going to give me plus or minus 8. Because it's a perfect square, I'm going to have 2 rational answers. And that means, what's that one go with? A. The answer for 16 is A. So let's look at 18. Now, in my class, we did a little chart and showed, you know, if the discriminant is such and such, then these are the kinds of solutions you're going to have. So you could reference that. Let's look at problem number 18. 9z squared plus 30z plus 25 equals 0. Okay, so all I care about is the b squared minus 4ac. All they're asking us is what kind of solution they are. They're not actually asking us for the solution. So b squared, 30 squared, minus 4 times 9 times 25. 30 squared is 900. And then I have minus 9 times 4 times 25 is, 900. 900 minus 900. Okay, so the answer is 0. So if I have negative b plus or minus 0, how many solutions do I have and what kind are they? Can I take the square root of 0? Yes, I can. Square root of 0 is 0. So if I have negative b plus or minus 0, plus 0 is whatever that was, and minus 0 is whatever that was. So all I get is negative b over 2a. That is one rational answer. And so that is B. Problem number 18 is B. Okay, that's it for 9-2.